So today we talked about average rate of change, which we said can be represented by a slope of a line between 2 points on our interval for a nonlinear function. So we use that notation A f of A and B f of B to write our formula f of B minus f of A over B minus A, similar to slope formula. And to actually calculate that average rate of change, we would just plug in the interval endpoints we're given into that formula. So the average rate of change was our first variation of the difference quotient. The second one is a little bit different in that we're not plugging in endpoints on our intervals. We're actually taking the function that we're given and we're finding f of x, and then we're subtracting f of a when we plug in a into our function, dividing by x minus a, and once we write that whole thing out, we're just going to simplify it, and we may end up with a constant, or we may end up with something involving x and a. So we're going to spend some time focusing on the last variation of the difference quotient today, written f of x plus h minus f of x all over h. So here's our same graph, and we're going to call this first coordinate x, and its value f of x. X is the distance from the y-axis. And then instead of calling the next point A and making that A units from the y-axis, we're actually going to call that x plus h and say that it's h units away from point x. So that's where we get x and then x plus h plus some distance. And then our y point for that is just f of x plus h. So we're going to look back at our old formula, f of b minus f of a over b minus a, and instead of using b and a, we're going to use x and x plus h and plug that in. But what happens is that when we get to our denominator, our x and the x plus h and then our minus x cancel out, so we're left with f of x plus h minus f of x divided by h. And you don't need to do that work every time. You need to memorize this final formula as your difference quotient. F of x plus h minus f of x over h. Okay, so let's try an example with the function f of x equals x squared. So first I'm going to want to find out what f of x plus h is, and that's just x plus h squared. Now I'm going to input that into my actual formula. I'm going to find f of x plus h, which is just x plus h squared, minus f of x, which is x squared, divided by h. All right, this is going to take a few steps to simplify. We're going to FOIL that x plus h squared. I can cancel out the x squared in the front and then the negative x squared in the back. And then I can factor out an h because I see I have an h in the two terms in the numerator. And after I factor that out from both terms, I can divide the top and bottom both by h. I can cancel them out. Let's try again with the function 5x minus 1. So first I'm going to find f of x plus h, which is going to be 5 times the quantity x plus h minus 1. And now I'm going to put both of those into my difference quotient. 5 times x plus h minus 1 minus, in parentheses, because that whole portion is negative, all of f of x is negative. And here you're just going to see me simplify this. It's going to take quite a few steps. I'm going to cancel some things out until we see that the answer for our difference quotient is 5. And that makes sense because this is a linear function, so our average rate of change, no matter what the interval is going to be, is just going to be the same as the slope of our line, which is 5. So I'm going to speed up these solutions really fast, so if you want to see exactly step by step what I did, you can go to YouTube and you can click on half speed setting to kind of watch it slower. But I just wanted to explain that when our functions get more complicated, we're just still plugging them into the difference quotient. It does get more complicated in terms of simplifying, but these are just algebraic techniques that you've been using and perfecting through Math 1, Math 2, and Math 3. So when we have difference quotients, we're going to want to pay attention a lot to factoring and grouping. So you'll see at the end of this that I do a lot of factoring by pulling things out that I see in different terms at the top of my fraction. So to summarize, here are 3 different ways that we can find the difference quotient. The difference quotient helps us find the average rate of change over different intervals of our function, especially when that function is nonlinear.